We are starting now a new video series for the Kubernetes security. So this is the very first video, and we are starting a concept of auditing, API auditing uh, in Kubernetes. How this works, what are the benefits, and how to configure it. So if I go to the documentation, here I can see the Kubernetes documentation. I type here the API auditing. So this is about the auditing, and auditing is totally based on the API and what requests are coming to API, who is connected with the API, and what is acknowledged by the API to the different users. So Kubernetes auditing provide a secure, relevant set of records, documentation, and a sequence of action in the cluster. So what we can do, auditing allow cluster administrator to answer the following question: what happened? When did it happen? Who initiated? On what did it happen? Where it was observed? From where it was initiated to where it's going. So all these question answers we can uh, do by enable auditing. So by default, Kubernetes, when you install the Kubernetes, the auditing is not enabled. So we have to enable it, and it will add additional overhead on your compute resources. So if you really need it, you can enable it. So now, if we look into the configuration part, so each request can be recorded with an associated stage. The defined stages are, there are 4 stages. Whatever request is coming to your API, you will define a stage. I mean, at what stage you want to record that specific request that is coming to API. So, normally whenever you are sending any request to any server, so there are 3 steps. I mean, request received to the server, and server the compute start the computing or whatever you requested on the server, but so far not acknowledged. If server is just gathering the data from some database or whatever, and after getting the request, after generating some specific resources or queries output, response complete. I mean, your requested query is acknowledged properly, so to the user. So these are the 3 steps we use normally in any request that is received by any API or any web server. So we will define these stages. I mean, any stage we can define uh, for any resource, API resource. And if we go down, we can see we can define the audit policy. And audit policy, you can define none. None means you don't want to uh, get any audit logs for specific resource. You only want to get the metadata, or you only want to get the request. Mean these 3 stages: when the request came, when the request processed, when the request acknowledged, the response body. So the request came, so what metadata, mean which user, from which IP, at what time, and what resource request, what verbs was requested. So metadata and request are almost same. there is very minor difference in metadata and request, but request response is different. Mean, what was the question? This you can say just like the question, and this is the answer. So what was requested from to API, what was asked to API is written in metadata and request, and what was acknowledged by API, that is request response. Okay, just like I have my Kubernetes cluster, I am not typing kubectl get nodes. So this is acknowledged me by uh, the API. So when I press enter, that was the stage of metadata I sent or request I sent, and the stage was request received. And for about 10th part of a second, it wait, and then at that wait time, you can say is response started. I mean, API get the data from the etcd and rest of its components from kubelets, and responded back this reply. I mean, one worker node is down and one worker node is up and one master node is up. So this was the response, response complete. This stage was response complete. But for every stage, you can get either metadata or request or a request response. So here is an example of our audit policy. We have to write our own audit policy, and then we will attach this policy with our API server. So this is an example of the audit policy. Uh, the audit policy API variant we will define, and this its kind is policy. Here we will define the stage. I mean, whatever we want to fetch for this policy, at what stage? What three stages I explained you. When the request receive, at that stage, whatever data is available, it will be uh, generated by this policy. And then we have to write the rules. Rules are basically defining what type of data you want to, for which resource you want to fetch the data. So here we can define the level. For rules, we can define the multiple levels. Just like this level is metadata, this level is request response, this level is none. Whatever these audit levels I explained you. Okay, so metadata and request you can say are just like same, but this is the acknowledgement of your query, and none mean I don't want to fetch any data. So here the level is written, and okay, I need response request, mean I query nodes and what was the response. So so resource I need to define under the level, and these are the basically API resources, and there is a group and then the name of the resource. So what is this group? I will explain you what is this group. If we go here and type here kubectl API resources, so these are all the resources in our Kubernetes cluster so far we configured. So here you can see the API variant. Okay, so API variant for bindings is V1. Okay. Similarly for events, for all these resources are V1. It's mean there is no group. But if you look the API variant something like this, just like daemon set. So daemon set API variant is V1, but it lies under the group apps. So these six resources lies under the group app. Similarly, these two resources lies under this group. So uh, before the variant, there is a forward slash and the group name is defined. So different API resources are a part of different group. Some are independent, some are not with any group. So these all are without any group. Okay. So similarly, you can see here this is a batch group. Okay. This is a custom resource definition group. Okay. This is Nginx org group version v1, whatever resource this is. Actually, this was created, these resources were created as a custom resource definition when we deploy our ingress controller. And so these are all the groups. So when we are defining here group mean nothing. Nothing mean those API resources I want to monitor that does not contain any group. So these resources does not contain any group. Okay. So I want to get filter, I mean, get the audit report for these resources. So then in the resource section, I can define any resource. If I am not defining any resource, all these resources will be entertained. But here explicitly, the resource name is mentioned pods. So you can see this pod lies under this V1. It does not contain any group. So similarly here you can see, and the request response mean whenever we are writing the query kubectl get pods, so whatever answer is given by API, that answer we need, mean request response. Here is level metadata. Metadata mean what was the query from the end user, and for all the resources that are not coming any under any group, and pod logs and pod status. Okay, so these are the resources we just want to get the data. Similarly, this level of rule is defining none. I mean, I don't want to fetch the data about the resource config maps. You can see config map is not coming under any group. So that's why group is empty. And you can define the resource name to mean there can be thousands of config map in your cluster, but what specific config map audit you don't want to get for this controller leader. So this will be excluded. So these are multiple examples you can see, and then you can even define the username. I mean, if this user generate a query and query was for the watch, mean get type of or get or list. So then uh, it will not be acknowledged, and for endpoint and services resources, it will not be logged for this user, for generated by this user for this watch. So similarly, you don't log anything about slash API resource and slash variant. Okay, and user group is mean users you can define. You can also define the user group. We discussed this in very detail when we did our RBAC portion. So these are the groups and users from in the RBAC we configured. Okay, so now if this is the request, mean what was the query from the end user for config maps, all the config maps, but in this specific namespace only, not for all namespace. When namespace is not defined, it will work for all namespaces. So this is just a sample configuration. And if you want to, you can use a minimal audit policy file to log all requests. Mean if you create this policy has one rule, and you want to fetch all the queries sent by to API. all the queries for all the API resources. So this policy will report each and everything, but it will make a lot of noise in your logs, audit logs, because you know APIs server is getting a lot of input all the time. We are running multiple engines in our Kubernetes cluster, you know, kubectl, get, pod -a. So you can see Calico is running Calico controller. It is consecutively communicating with the API server. Similarly, core DNS is consecutively updating its data to API. etcd is acknowledging, is doing. So all the components, API is the center point of our Kubernetes cluster. All the components are communicating to API. Controller manager is consecutively interacting with the API for the server health, for the cluster health. Similarly, kube proxy is getting the updates from API. Scheduler and metric server we deployed in what pod, what resources are used for which node, and which how much resources are used for pod. So these are all resources are, these all components are consecutively engaged with the API. We as a human are interacting by the command line, but these resources are interacting to make the cluster active. So I will just generate this one and I will show you how this policy works. Then we will make some filter on this policy. We will just generate some logs for specific API source. So let me, if we go down, we have to modify our Kube API pod with some settings. Mean this audit log path we have to define, audit log max size we have to define, audit log max backups, mean older log rotations, and max age after that log will be deleted, and audit log max size, max age, and these are all parameters we can define. And this parameter we have to define that where is our audit policy file is, that I showed you, this one or this one, whatever we will generate. So we have to tell the API server where our audit policy file is placed, and where audits will be written on the server. This parameter we have. So it means 1, 2, and 3, 4, 5, and 6 parameters we need to define in our API server to make it work perfectly. And this path will be, mean when we will define this path, mean this path will be inside the API container. But we will set up these files on our worker node, master node, and we will give these files references, these file references to these file references by host path. So we will map the volume. Okay, so I will explain you how this will work. So let me just go to my master node. I have only one master node. If you have multi-master cluster, you will do this activity on all the master nodes. So I have my API server up and running, and you know, its manifest is under the Kubernetes manifest. And here we have Kube API server YAML. So these are the default, this is the command that run inside this container. Which container? Here is the image. This is the core image of our API server. And the command is Kube API, and these all are the parameter to this Kube API core command. Okay, and then your API is automatically starting. So I have to add here my own uh, new parameters. So first of all, I will define these two things. Okay. So audit policy file, I am saying that within this container, API container, under this etc Kubernetes audit policy file will be available, and inside the container it will write the logs under var log Kubernetes audit.log. Okay, and what else I can add? I just wrote a template here. I can define these parameters to mean to define the log rotation of our this audit log. So it will rotate the logs, mean max log size will be, I can say it is 10 megabyte, and max backup folder 10 file it will be saving, and max age 30 days. So these parameter I defined, and what else I have to define? Mean I need to create this audit policy file to on my host machine. So I will create somewhere on my host machine, and let me open a duplicate tab, because when I will save this, it will restart the API server and this policy will try to apply. And since these files are not available inside the container so far, so maybe our API server will not be in healthy state. So we must have to configure the API server properly. So first of all, I will create this API, this audit policy. For example, I am creating under the etc Kubernetes. I can say audit and create a directory with the name audit. Okay, and under this directory, I will create a file or audit audit.yml. Here I just put this policy. Okay, mean report for all the resources metadata, and I can create here one more thing, mkdir logs, and under this location this audit policy will write the logs. So now what I need to do, if I go down, you can see this is an example of volumes I can create, and volume path will be host path. So host path will be etc Kubernetes audit that contain audit.yml, and etc Kubernetes audit/logs that contains the logs path. So that whatever written inside this API container will actually be pointing to our host machine. So here in this file, in this volume section, you know, all these host paths are pointing to our host machine. So let me just quickly fix this indentation. Okay, so what I just copy paste. but these paths are wrong. And this path is not actually the path on my host machine. Actually, it's under the etc audit slash audit.yml. Okay. And just to make sure I am doing the right thing, I will do a cat on my host machine to make sure this is the right path. Sometimes there could be a minor mistake that can make a problem. So this is a type of file. We are directly providing a file or this file inside our Kubernetes cluster. And audit log. Audit log, I create the directory under the Kubernetes audit and logs. I think I created logs. So better to run this pwd to select this and copy paste it here completely to avoid any error. So create or directory or create. If the directory is available, then it's good. If it is not available, then create it. Now we will map these two volumes. We don't need to write this volume because volume is already written here. We cannot write it twice. We just need to delete this. So we just add an audit name volume and audit log volume. So we can also say it audit policy. Okay, and this is audit log. And here I have to define where to mount it under my API container. Volume mount I don't need to define because it's already on the top here. Here these paths are not good because this audit policy, this is audit policy, not the audit. This is audit policy and that was audit log. Okay, audit log is good. Now I need to map these paths where this audit policy volume will be map in the container. So it will go under this path. That is wrong. That path should be this path. Okay, I'm just making sure that everything is whatever I define in the command of the API startup command should be according to the file. So this file will now be mounted inside the container from this path on the host machine. And second, this path will be mounted etc Kubernetes audit log on my Kubernetes cluster on my API container var log Kubernetes audit. So let me just check what I var log Kubernetes audit. This path will be just to make sure this path will be mounted. And in under this location, I mean, this is under inside the container that is pointing to my host machine to a different path, and file name will be audit.log. So I think we are good. We just need to restart now our API server. So how CRI CTM? Yes, you can see the API server is up and running. So how we can do, we can move this file Kube API to some different location for a while. You can see after some time the API server will be, oh sorry, yeah, the server is still running. It will take a while to shut down. Yes, API is now stopped. If I query now kubectl get nodes, it will not respond me because API is shut down. Now I want to bring back my API. So what I will do, I will just move back this file to this location. And now it's starting the APIs. It is back. Now when I will be query to kubectl get nodes, gets back. It's mean this is running, mean we have not done any error in our configuration file. If we made any indentation issue, error or some spell mistake, it will not start. Then you need to go to what location under the var log containers. Okay, whatever containers are running on this master node. So ls minus ltr, you can see here all the running containers on this machine are generating logs there. So you can consult to these files to look into the what error happened while starting that specific container. Just like Kube API server, this is the log. It is actually here, but this is a soft link. Okay, so just you can follow this file to get any uh, problem creating container. So this was just about the troubleshooting. Now, if I go to etc Kubernetes and here I created the audit, and here this file is mounted inside our container. Okay, it started, and now if I go under the logs, you can see this audit log is created and how quickly the size of the audit log is expanding. If I do a tail -f to this audit log, so all the queries coming to this API server are reporting here. So all, I mean, what type of queries are coming here, I will show you just a minute. Let me just stop this. So this is not a good idea to just report everything. It will be difficult to understand everything because we don't need everything. We just want to filter according to our requirement. So just an example, kind, event, API variant to audit. Yes, this was the audit variant. Level metadata we defined. This is the audit ID. And stage, at what stage we are recording, request receive. I define in my uh, uh, audit file. In this file, metadata. So stage by default, stage we have not defined, but stage is by default request received when we are not defining the stage in our API, this policy file. So request URI mean when the request is coming to your API server. So actually our API, if I hit to my API server, for example, I am sending a request to my API server. I know my API is 192.168.151.6443 on HTTPS. So this is the normal response, but the complete URI is something like this when we are sending request to. This is the complete URI. So, but it will not respond me. I'm just showing you how actually the URL is generated when you are requesting to API. It will not respond me because I am requesting without any token, just from the browser. It will not work. So this is the complete URL generated by this request came to this API server, and verb. We discussed verb in detail in our RBAC videos, and the request was to update something by which username was some this was some uh, system user service account, and that name was cube scaler. So it means scaler something ask to update. Okay, and from this group and from this source IP this request came. So actually the scaler is running on the same machine, so that's why the IP is the same on master node. User agent cube scaler, which variant was used, from which operating system request came, from Linux machine. Okay, so and from which namespace cube system. Okay, and resource leases namespace and name cube scalar API group and timestamp. So this whole story is written here. What happened at what time and what was requested by which user. Okay, so now this was just an example, and if I show you some other uh, example, just like this was the API resource endpoint slice in the namespace default. Okay, and for the resource endpoint, so now I will change my audit policy. This audit policy is fetching everything. So I need to modify audit YML with some meaningful data. So for if I go to this documentation, here you can see the resource I will define. So here I just change that I need only metadata level of auditing for no group, and the resource is part. Okay, and one more thing I will add here. It's not mandatory by default. It's request received. You can also add here this one. So request received, request started, or response completed mean these three things mean when this thing will be reported in the log file, when response received, or when it is computing the response, or when it is acknowledging the response. At what stage it will be written at in our log file. So by default, sorry, I just need to add this part, stage. Request receive. As request receive, it will be written in our a log file, or so for the pods only. Okay, or I can say config maps. I believe this is the right syntax for the multiple double quotes I need to define in with comma, space, and double quotes. Config maps and so for these two resources, I will now report. So let me just save this and let me go to logs, and I'm removing this log file because it contains a lot of data. First of all, I will stop my API server. Going to the second tab, see Kubernetes manifest, MVQ, BPI, CRI, CTL, PS. It will stop. The server is running. It will take a while to shut down. It's shut down now. Now I will just delete this file. I want to see a new file with just relevant information. I'm starting now. So I just moved this file here, and it should now start the API server. API server is started. And if I look into this log, now it's generating a new log with the audit policy updated. So here you can see some metadata is coming, but only relevant to pods. I mean, right now, I am not making any request to API for the pod or config map information. But when the API server is starting, so all the components that are communicating with the API, and just like controller manager or scaler, uh, and kube proxy and metric server, whatever we set up, are getting the updated information from the API server because it was down. So when you will start the API server, initially you will see these informations, and when all the informations are updated, it is now stable. So these requests, let me show you what happened. You can see the resource config map in the namespace kube system was requested by from this IP. From this IP mean this is our worker node IP, and some component maybe is running on our worker node. I think some controller was running as a pod, and this was the URI I explained you in detail. And what else? From this worker node, yeah, this is also written. I mean system nodes, there is a group. System authenticated, this is a group, this IP. And from the kubelet agent, this request was generated for this resource, metadata, and what time. So this is the complete story, what was requested, what was the query came to API. Similarly, if I show you some other request, so let me now generate my own request. So I open the second terminal. If I type kubectl get nodes, it is not reported here because I have not write the policy to get the to audit for the nodes information. but I want to audit for the pod. I want to get the information about pod. You can see it is reported here. So here, this is the audit ID, stage, response complete, and this is a URI verb list. I mean, when we are using a get, so verb is list. Which user? Kubernetes admin. So what file I am using if I run kubectl config view, and you can see our username is Kubernetes admin. I can config get context. So this context I'm using, this is the user. Okay, so same user is trying to hit my API server from this group, okay, from this source IP, since I am querying directly from my master node. And kubectl variant, this variant used on from this machine from where I generate this request. What resource I asked for the pod in the default namespace. So if I do now kubectl get pod -n dev namespace, so you can see now a new audit report is generated, namespace dev pod. Okay. And now let me open from my Windows. And I believe I have just want to check cube config variable. Okay, we generated this, and I just want to check kubectl config get context. So the background logs you are looking here, these are the consecutive updates from the cluster, other components about pod and namespaces. Okay, we have these two context. I think this cluster we deleted. So let me just quickly use context developer context because this cluster is not available right now. This is our current cluster. Developer context. Get context. kubectl get ctl get pods. Yes. So now this developer user don't have the rights to get the pod resources from dev namespace, from kube system namespace. Can it get? No. So API auditing is showing me, let me generate this again. Someone from the Windows machine is trying to, from this IP, this is my Windows IP. And which user? Developer user. Okay. And name on this namespace I requested. So for which resource, everything is written. So since these are the other components trying to communicate with the API for the pods and namespace. Now, if I query from dev, okay, now if I query for config map, cannot. So you can see the config map resource. Developer user tried to cannot list resource. It is also reporting. So it's mean the status is failure. Wherever it is successful, it is true. I mean, a successful or failure is reported. So this is the complete audit. I just generated a very simple log for you in front for these two resources, but you can modify this policy according to your requirement. So far our policy, if I go to my policy again, audit YML, this policy is only working on these two resources. So we can add multiple resources. We can add more rule here. Okay. And or with a specific user, with specific resource name. I mean, it depends on your requirement. I just gave you the idea how this is working. I just gave you the idea for the two resources, but you can generate your own custom policy. So, so we implemented this, and if I want to see these logs, actually these logs are difficult to read. You can actually these logs are generated in JSON format, but it's not represented here. I mean, this log you can see in JSON format too. If I do a cat to audit log, pipe sign JQ dot. Okay, so JQ is a command, is a tool in Linux, jQuery, that can show you a simple text file in JSON format. But just query, run this command to generate this audit log file in JSON format. So here it's very easy now to read. This is a complete event. Okay, this event is kind, API variant, metadata level, audit stage, everything is now very clear format. Source IP, what was the request, who generated. Okay, this was this is the, who generated. This is the resource, and user agent was this, and this user actually tried, this user or this group tried to hit and get this information. So if I show you, I generate just config map and pod by, now you can see the pod happen failure for the developer user. This message was acknowledged, and username. Okay, so this is now easy to understand at what time this happened for bit. So with this way, you can keep an eye on your API server in production, what is happening when you are generating multiple role-based access control and you don't know what is happening on your cluster. So this auditing can help you. You can directly generate the log file in JSON format if you add this parameter in your API config manifest. So right now it's just generating a straightforward text file, but I converted that log into by using jQuery tool into JSON format. But if you add this, it will straightforward generate in the JSON format. And what else? So this was all about this audit. This is a webhook backend. You can add this parameter, audit webhook config file, audit webhook initial back off. So webhook audit backend send audit event to a remote web API, which is assumed to be a form of Kubernetes API, including mean of authentication. You can configure a webhook audit backend using the following kube API flags. So just like we add these parameters in our config file, config map, manifest, in the API manifest, we need to add these two parameters if we have some specific API server running that is ready to fetch the logs. And then it can process the log and generate some specific reports. It depends. Maybe it could be some security system you deployed that can give you some API to fetch the logs. And in that case, you will define that server, that API URL by using these parameters. Its configuration is not shown here. I mean, it can be any uh, application that has the feature to read these audit logs and generate some specific web UI proper reporting system for you. So far, we are just working on the command line. So as a human on the command line, it's difficult to manage. So we just generate the raw logs to make it meaningful for some dashboards or for some alerting system. You can set up some another system that can fetch these log and perform some specific action for you. So if you read this documentation, you will get the idea how you can connect a webhook backend to fetch these logs and process these logs for some meaningful output. Okay, so this was uh, for this was the audit log, everything I explained you in this session.